Hello everyone, I am Harika Shinde. I am from Institute of Aeronautical Engineering and I am from Computer Science and Engineering branch. Today I am here to share and present my AET Tech Talk video of a course Theory of a Computation. My topic is the diversity crisis in software development. Let's begin. So, what is first diversity classification? Diversity refers to the variety of representation that exists within a group based on a large range of facets and characteristics. Diversity is thus multidimensional and its relevant parameters depend upon the particular and situated practice under scrutiny. In software development, diversity is relevant to the groups of people involved in the field's practices and to the technical designs emerging from those practices. Hence, facilitating diversity involves studies of software development approaches and investigations of the technologies that result. The question then becomes what are the relevant diversity parameters we should consider when exploring software development practices and technologies. Given the multifaceted complexion of a diversity and the general purpose nature of a software development, it is important to acknowledge that we cannot come up with one size fits all classification. So instead, we discuss the core categories that often emerge in such research, in particular gender, race, ethnicity, and disabilities. Gender is probably the most applied diversity dimensions within software development, particularly since computer science and technology professions are known to lack women despite the fact that programming was originally seen as a female occupation while hardware design was viewed as a realm for males. Although we have seen increasing amounts of research investigating the experience of a woman in a software engineering, we want to make it clear that the gender is not a binary classification. Thus, we encourage studies that explore experiences along the gender identity spectrum, including trans and gender non-conform developers. We urge the research community to consider the multiple sets of gender classification when performing empirical studies. For example, when conducting surveys, we draw on the recommendation by Scriban to make a gender multiple selection question, including the classification of women's, man, non-binary, and prefer to self-describe. These best practice as well as others can help our community carry out inclusive research and log gender diversity in our studies. Race and ethnicity in particular re-entered the political arena in 2020 with a Black Lives Matter movement intensifying in the United States. In computing research, studies involving racial and ethnic minorities have included the impact of a mentorship, the experience of a computer science students and advanced academic careers in computer science. As impactful as that work has been, there is a lack of a knowledge about racial and ethnic minority experience among full-time software developers because race and ethnicity are not globally applied uniform concepts. We face a question: how can we collect data about race and ethnicity within a global software development in our attempt to increase the percentage of people who are not white and those who thus do not have a privileged position? We propose that when conducting global studies, we extend the parameters and dimensions of the race and ethnicity classification scheme so that we can consider a category in which subjects self-describes in relation to the country of residence. Similarly, since the race and ethnicity classification makes sense only within a geographical and social boundaries, we cautiously encourage properly prepared studies within these bounds. Further, it is critical that we consider people's varying experience of what it means to be a software developer, how these experiences are shaped by where in the world people engage in the field, and how we are researchers conducting inquiries into those experiences. For instance, by considering the power dynamics that arise when outsourcing occurs between the global north and the global south. So, cultural taxation, intersectionality, and Imposter syndrome. While diversity describes the variety of representations that exist within a group, inclusion refers to whether or not participants with different backgrounds are invited into a group, given full membership, and have a positive experience. Thus, the question is, what are some of the core barriers for increasing diversity within software development? While individuals might experience multiple impediments to software development, education, and professions, we would like to point three important challenges to inclusion, namely cultural taxation, intersectionality, and imposter syndrome. Cultural taxation was introduced by Amado Padilli 32 in 1994 and refers to the extra work and effort forced upon ethnically diverse academics. Cultural taxation is defined by Padilla as the obligation to show good citizenship towards the institution by serving its needs for ethnic representation on committees or to demonstrate knowledge and commitment to a cultural group. What is important here is that if we want to promote inclusion in software development, we must acknowledge the cost that minority practitioners pay in time and effort, and remember to value their work by using more than mainstream metrics for promotion. However, it is not just the developers who may experience this challenge. Scholars who conduct research in a diversity area related to their personal experience, example, gender research in a computer science, and who are dedicated to fostering change, often and up having dual research careers. As formulated by Padilla, the choice between conducting ethnic research or mainstream research frequently includes concern about how ethnic research might be viewed on a tenure application. Cultural taxation, sometimes called the minority tax, exists for all types of diversity dimensions that are relevant to software development. Example, gender, race, ethnicity, and disabilities. Intersectionality explicitly demonstrates how diversity dimensions such as gender and race are not mutually exclusive categories but intersecting ones. Cambry Crenshaw, who introduced the concept, showed that because anti discrimination laws are built along single axis, discrimination becomes a multidimensional experience. This means that people who are embody multiple diversity dimensions are lost at the intersections between characteristics and theoretically erased. In this regard, the huge challenge for software development is that a diversity classification scheme risks blinding us to specific challenge faced by people who embody multiple traits. We might create incentives to increase gender diversity in computing but fail to consider ethnicity and disability. Diversity and inclusion software development, this special issue focus on these issues. This special issue focuses on this issue of diversity and inclusion in software engineering. We were fortunate to receive submissions to this special issue. We briefly described them in a section and hope they help achieve in our goal of spreading awareness of the diversity challenges we face while also equipping readers with guidelines and best practice. The first article, How Trans Inclusive are hackathons by Par.al, describes a study where the authors surveyed 44 participants and interviewed 7 participants to understand the needs and challenges of the transgender community and other minorities in hackathons. The article explains that hackathons are an effective place for people to learn, work on collaborative projects, and meet new colleagues. Although most people enjoy participating, some transgender people decide not to join in because they feel uncomfortable. Based on the findings, the author suggests guidelines for making hackathons more inclusive for trans developers. In impact of affirmative action on female computer science and software engineering undergraduate enrollment, Simon's focus on diversity in the next generation of software engineers. They observe that affirmative action programs to boost female enrollment can have positive effects for science, technology, engineering, and mathematics programs. However, the initiative yields weaker results for computer science, software engineering majors. This means that to encourage the women to consider computer science, software engineering, this program should complement enrollment quotas with other interventions. Gendered experience of software engineers during COVID-19 crisis was a timely submission about technology professionals pivoting to working from home during the pandemic. This article explores how gender impacts their experience and how work family arrangement affect women and men differently. The author makes suggestions for better supporting gender diversity in this context. Finally, in combined institution and rationality increases software feature novelty for female software designers. Prettiers et al. Describe an experiment where 80 developers were asked to perform a software design task. The authors examined how design novelty correlated with the developer's gender and preferred cognitive style, which they defined as intuitive, rational, and a mix of the two. They found that women produced more innovative designs and that women who used an initiative or mixed cognitive style were more prolific than those who employed a rational approach. We hope that some of the submissions we could not accept due to limited space. As the articles in these special issues show, challenges related to diversity and inclusion are at the forefront of modern software practice. We look forward to research that tackles this important subject. Thank you.